This is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST Robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
Okay. So Scott is not here today. So I will be leading a discussion about prototyping. This is gonna be more open. I don't have like any slides or anything fancy. It's just more about what do you guys do to prepare for prototyping? What do you do to ensure that your prototyping like phase goes smoothly? And then like game analysis. What do you do like for like rapid prototyping parts? But anyways. So I'm gonna start with that first question of what do you all do to like prepare for your students for prototyping? Do you do any like prototyping training or like design training? For Nightcrawler, we use mini trials, where our students they get to design the robot by themselves basically, and everybody basically takes a step up. So, oh, okay. Um, so the new students become or like take on the role of returning students. However, returning students take on the role of captains, and captains kind of take a step back as mentors. The mentors just make sure people don't hurt themselves. And then what that lets us do is that it lets our new students gain independence in the prototype process because they get to I'll go through how to prototype a robot, and then it also lets them explore like why we have like design rules and whatnot. So that's what Nightcrawler does for prototyping design training. What do you guys do? What do your teams do?
So 3926 also uses mini trials for prototyping training, which has been super helpful. Although with the shortened length of the season, what we've done at least this year is we made a prototype, then we figured out what worked about and what didn't work about, and then we kind of moved on to the final robot. So it was only like 2 steps of iteration compared to usually a lot more steps of iteration that go on between prototype and final design that we see in the off on season. um I think that one of the things that has been helpful is we usually split into like multiple different groups to prototype different ideas, and then once we see the prototypes we are better able to weigh like the pros and cons of each of them, but that also has the downside of it takes longer to build both of them.
And I can probably jump in for Mythic here, because I guess we're kind of similar to both those. Because we've done many trials this year, we've done the past few years, and that's been super helpful with training and prototyping. This year, how we did it was we split it where all of our new students are doing mini trials, and then all of our returning students were doing a sort of off-season project. So all our returning students were building an elevator because that's something that we don't have a lot of experience with on the team right now. And so they went through that whole process. And so they made a few prototypes, did all the CAD, and are sort of working on a final one now. So that's the sort of thing that I would add on for what Mythic has done.
So not so much more of a success, but more of a challenge on Talon for us. In the past few years, we really haven't been able to do prototype training. Typically, the way it would work is we would have upperclassmen who know how to do prototypes, and they would go off and do on their own thing. But then they would bring new members onto their prototype and have them like help CAD out little bits of it or machine some of it. And so it was less more of like pre-preparation that they just kind of learned on the job. This year, we're trying to do a lot of different things. We're starting with just having people learn CAD, and that's already helping with prototypes, but we haven't really gone into the design.
Okie doke. And then the next question would be like, do your teams do anything before your prototyping phase, like in the season, that helps make sure that phase goes smoothly? So, what Nightcrawler does is that, well, we find that what makes prototyping so long is that we just have like so much to prototype, so we focus a lot on our game analysis and strategy to really narrow down the ideas. So we have like design tenants that help filter different designs that just don't fit with those like rules. Like for example, we try to use wheels to pick everything up. We generally try to stay away from claws. Um, and then our game analysis helps us figure out a strategy, and then we base a robot around that strategy. So in the first few days after the game is released, we as a team come together and just like go through the game manual, and then we figure out, okay, this the design team is like, these are the possible strategies that we might see within the game, and then we do something called human robots, where our students basically simulate those different strategies by acting them out, like walking as robots, placing pieces, and then that helps us narrow down our strategy and then base our design around that strategy, and then that usually helps us like figure out, okay, we probably want a robot that does X, Y, and Z, and then we go to design and figure out, okay, what do we need to do to complete X, Y, and Z.
Just to piggyback off of what you were saying, Kevin, I think another thing that we've really addressed in the past couple years with the human robot simulation has been this idea for our students of robot archetypes. A lot of our students really want to get very focused in on like how exactly would we do this thing, and so we like to have them think more broadly at first about, okay, is this a high goal scoring robot? Is this a low goal scoring robot? Maybe this is a robot that's a little bit more assistive. It's bringing game pieces, and like keeping things very high level before narrowing down into, okay, do we use an arm with this type of claw in the end or this wheeled intake? Thinking about the archetypes first allows us to think a lot more about like whole game strategy before we get straight into very technical questions. Also, just to add on to Kevin's question, I think it would be interesting I've just personally wondered, like, what does the research process look like on other teams? Is that something that you all do? Like, I think about as I'm a senior, like, okay, I'm leaving, and how do we have that kind of like generational knowledge on our teams? And how do our new students come up with ideas? And so the way that teams pass down information or look for research, whether that's looking at like past designs, could also be something really cool to learn or share about.
Yeah, I can probably talk for Nimithik here. Because in the past we haven't really done a whole lot of research or stuff like that. It's mostly just sort of been, I guess, students that have been on the team for a while, our mentors that are like, oh, this game is similar to such and such game. Like last year, I think we looked at, I think 2011 was a game that we looked at. It's like looking at other like past games. But this year we're definitely trying to add research as a fun sort of step in our process.
Yeah, at 3926, we also want to add more research into our process, especially looking at how previous games have been similar or different to these games, and like how you can kind of take away from it. Like, I think, for example, one of our blind spots in 2022 is like, how are we going to do this multi-run climbing thing? It looks really hard. And if anyone had seen any of the robots from 2020 or 2013, then it's like, okay, this is example of how you do something like that, and being able to show that, or like knowing that a second roller would be good to eliminate backspin for the cargo when shooting into a goal that has the possibility of bouncing out. And so right now I'm trying to compile like just simple overviews of each, like the past 10 games, with some examples of simple robots from them that have been successful, and I'll see how that works for our team this season. But then also, I think part of it is figuring out how to get teams to look at or members to look at Chief Delphi, because there's at this point almost 100 Open Alliance teams, right, that are all putting out stuff on kickoff week, and it's impossible for just one person to read them all. But I think if there was a structure for like a team to do it as a whole, that might be very helpful.
For Team 4009, one of the things we've had several students over the past few years that have gone to Jumpstart and seen the Manipulators Workshop, which is available online through the Jumpstart website. And I encourage people to go and look at that, because he breaks it down by game piece. And how many times has a 9-inch ball been used, or a 13-inch ball, and what years have they been used, and what type of climb has been used every year, so you can look back at that. And see what worked in those years. And another thing that we do is we've had a couple students that have gone on to colleges that do robot in 3 days, and we will quite often live stream what it is. We usually do North Dakota, because that's where most of our students have gone on to, and we kind of we have it in the background, so we're not just sitting there for 3 days watching robot in 3 days, but we get ideas from them. If you saw our funky climber for Rapid React that swung, we borrowed that from the University of Minnesota. Their robot in 3 days team tried to do it. They never got theirs to work. We did, so we were kind of proud of that. But so that's another option, is to look at robot in 3 days, what they're doing, because that'll give you some ideas really early on in what works and what doesn't work. And then that passing down that knowledge that's there. I'm going to use an example of one of our students this year, who actually took a step back from leadership, because he would have been right up there for our team captain. But he's our programmer, and he's been our programmer for 4 years. He's one of our only ever 5-year students. And he said, I want to step back and teach all of the programmers that are coming in. And we were lucky enough to pick up a former Nightcrawler student, Ian, who has been working with him, and they have absolutely come up with some amazing things to do in autonomous. So, and they broke down the sub team or the programming team into sub teams, and assigned students to work on different things. So they're taking that knowledge that had been in just one student's hands and spreading it out to multiple students, to do that. So it's been really good to see that that knowledge passed on.
I guess like with that base knowledge, are there any like fundamental rules when your teams use when designing robots? I know I talked about like how Nightcrawler only uses wheels for like your intakes, but I'm curious to see what other like base rules you guys use.
Just one example for us on Talon, we force ourselves usually to use either one of two different type of like frames for our robot. We have a Raptor frame, like a preset Raptor frame for using tank drive, and then we have one for using swerve, and we try to stick between those. It just makes it a lot easier for our programmers and everyone in the season knowing what drivetrain we'll have, that it's one of two. But other than that, we don't have too many. We try to enforce wheels on all of our things, like Nightcrawler. But we're trying to expand more this year. So if you guys have any other suggestions for your wheel, like different, I like to call them design principles.
Our design principles, I guess we kind of have two of them, where it's the first one is the same as like, using wheels for everything, touch it on it, which is, the boring one, that everyone has, it seems like. But then the other one that we try and do is we try and keep a philosophy of, at least this year we're trying to, because something we've struggled with in the past couple of years, if you've seen our robots, is we sometimes have a habit of overcomplicating, pretty simple tasks. And so our goal this year is to do whatever task we do in the simplest way possible, and that being our metric for what we choose to do. So for example, for mini trials, we had two different options for what we wanted our robot to do, and we didn't have the wheeled only requirement for mini trials because we want to teach students kind of how we design through that. But um what we kind of did was we still wanted them to go with the philosophy of like, do we want to do necessarily the simplest way to achieve a goal. And so we had to have two options of either doing a conveyor belt thing that we saw a bunch of teams do, then the dumper we ended up finalizing. And because we had a really tight schedule, we only dedicated 8 lab days for mini trials. We ended up choosing to do what we thought would be, the simplest way to achieve the goal that we wanted to.
Ian, so how do you guys measure the simplicity of a design? Do you guys have criteria for that, or do you just go off of, well, just comparison between two different designs? Like, how do you see the problem
So
in a design's complexity?
we don't have a specific, metric for it, and I think that that would be something that would be good to develop. But I think it's kind of a combination of a few things, right? Where it's like, has the team done it before? So, like for example, if your team does elevators a lot but not arms, an elevator is probably going to be simpler to pull off than an arm. Or in our case, last year we chose to do pneumatics for the first time since 2016, and that added a lot of complexity because none of us really knew what we were doing when we were setting up a pneumatic system. So we had a lot of tube failures and things like that. Um, but then also we like thinking about degrees of freedom. Um, and so specifically, how many layers of abstractions you have to get to. Abstraction's not the right word. But to get to um, where the goal is attempting. So, like for example, a triple jointed arm versus a double jointed arm last year, right? A double jointed arm has one less degree of freedom, which would be simpler, like an arm on an elevator or a 4-bar on an elevator. We might consider to be simpler than a double jointed arm, because an elevator, you only really have to worry about it going up and down, and if you have pneumatics for the 4-bar, then it's just it going in and out, compared to if you're making a double jointed arm like a lot of teams did, right? Then you have to worry about, you get more positions, which can definitely be a good thing, and if that's what the team's goals need it to be, that might be the better option, right? But that's also kind of a trade-off with simplicity. However, also I think if our team was really familiar with arms, then a simple double jointed arm might have also been, something that we could consider simpler if we, weren't well versed in elevators.
I have a question on pneumatics. Do some teams go in saying that they're going to choose to include pneumatics or not for the season? That was a choice we made last year for the first time. We said This is Talon. We decide we're going to do a year with no pneumatics. And whether that was right or wrong, I don't know, but we just decided we're going to try a year and totally avoid it. So there's any other
The reason we decided to go for it was just pneumatics added a lot of weight, and we thought we could take that weight out, but it also added a lot of degrees of freedom. So that was kind of a big con for us. Sorry, Eric, you can continue now.
Yeah, that was the same. Our previous tank drives are going from high to low gear needed pneumatics, and going to a swerve drive, we no longer were required to have it. So that took off. Okay, my guess, we tried to say last year, let's do a robot without it. And as I said, does any other team go into it looking at it that way?
So I know that last year, I think our team definitely had the no pneumatic. Well, we hadn't done it since 2016, so we definitely had it. Where our reasoning was kind of that, the way, and I think right now we're also seeing a lot of like the really, really high level 1678 254 type teams avoid pneumatics for those reasonings. But I think after last season and mini trials, our team's more leaning towards pneumatics, especially for things that only need, 2 points where they're at, or even, just 3 points where they're at, right? Because what we noticed is that it's a lot easier to do that with pneumatics than it is to do with a motor in terms of just iteration time, design time, right? You don't have to worry about gearboxes, you don't have to worry about gear ratios, you don't have to worry about, offsets and all that. And it's, if you have the people in CAD who are, able to measure 1 point and then measure another point and find mounting points, which is not the hardest thing in the world. We noticed that it's just a lot quicker to go up for everything. And so, I mean, it's definitely a trade-off like most things in FRC, are, because you have to sacrifice the weight of the compressor and having a second system to go through your robot. But at least right now, we're kind of leaning more towards using pneumatics for as many things as we can rather than the other way around.
Right. I was very impressed by the Patriots' use of pneumatics. Worked very well for them, and that was something to learn from, I guess.
Yeah, and then adding on to basically what Ian said, for the past few years, Nightcrawlers had the design principle of if you have 2 positions, just use a piston, because it's easier for our programmers to program, and then it also cuts down the iteration time, like Ian said. But recently, this past year, we ran into problems of our pistons actually limiting our autos. Because we're using pistons for both our intake and our soaring. We ran into just first we ran out of air at some points, and then we also had problems where it just wouldn't go out fast enough. So we've been recently trying to experiment with switching to motors instead of pistons, but I just thought it was cool to see like a flip perspective of that.
Yeah.
To add on to, sorry.
I was just going to ask if people had been looking at the new compressor that Andy Mark released or tried that out, because it said on their website that it should be the fastest compressor that's FRC legal, but I haven't looked into it too much. I'm not very versed on the different compressor options.
If it's the one I saw, I just looked briefly. It looks reminiscent of another one that we had used back in 2015. I think, and I didn't look at the specs, but this one was also rated at 100% duty cycle versus the standard ones we have. I don't know if they're 5 or 10%. So you could run that compressor, not just through an entire match, but continuously, and it won't overheat. So, but also at the cost there is the weight. The one that we have from 2015 looks similar in that it weighed as much as several other compressors. So there's that consideration as well.
Have teams switched over from the brass fittings to the plastic fittings to save weight on the pneumatics?
Yes, I think I know for Nightcrawler, we still, I think the rules say from the compressor you need to have brass fittings, hard fittings, up until like the pressure valve, the pressure sensor, and whatnot. But after that, I know that a good use of your vouchers at Automation Direct, they have really small inline gauges and also regulators and whatnot, and all of plastic fittings, hose. It's a great source for the pneumatics that you would use in robotics. So I recommend using it there, but those are huge weight savings, cutting down that brass, except for the bare minimum. And then also, going back and how you design, designing your robot for auto and for the end game. And and then also like we were talking about with the, different positions, or if you use a motor, also take in consideration, you can build a very simple design mechanically, but you may find that if you don't think it through or get it, you may find that it could be very hard for the programmers to control the way you want. So it's balancing both of those. If you are going for a simple design, it also means you have to think about the programmers ahead of time, or have them in that process to help decide, is this going to be easy to do all these different positions or not? And so consider that as well.
Actually, that's my biggest tip as a programmer. Always, always, always include programmers in your design and prototyping process. You will save yourselves so many headaches.
Yeah, we on 8234 have, as we're developing our design standards for this upcoming season, we've, with approval from our programming lead, have decided to go for the no pneumatics, just because we have a lot more access to brushless motors now, so we can have more power in place of those pneumatics. Whereas before, we were pretty much limited to, we had 2 Falcons and then just 775s for everything else. But now we have more brushless motors. So we're just phasing out pneumatics this season, unless we decide that if we absolutely need them to play the game.
Right. And then for your next question, what do you guys use for like rapid prototyping? So what I mean by when I say that is that like parts that allow you to attach things like motors and bearings and those type of parts onto your prototypes faster. And then an extension to that of like an extension to rapid prototyping parts is that what are your guys' use of rigs? Do you guys use rigs at all to prototype? So those are basically like mechanisms that are focused on figuring out like different variables like compression or real type for your prototype.
So for us, we're really getting into rapid prototyping this year. Usually what we do is we have 80-20 bar, and we have a CNC machine, and we pre-cut out like motor mounts and stuff in fiberboard that will fit onto 80-20. So we have various bars that we can slide fittings onto easily, and it allows us to tension belts. We have 3D-printed pulleys. So it allows us to get either riggings built to the test. Usually we like to test compression on whatever pieces that we get for the season. So it allows us to test that, test intakes, arms, all kinds of stuff, and it makes it really easy to drive things with motors rather than taking a drill and putting like a 1/4-inch bit on it and just spinning it. We also just, with fiberboard, we can CAD out full structures and connect those together. We also recently, I'm not sure what you would call it, but basically we made a 3D printed bit that can slide through a 1x1 shaft. and you can rivet that into place. And then inside the 3D print, we put a nut in there. And so you can have bolted mounting on a 1x1 very easily. That's just a few of the things that we have done.
Yeah, and then for Nomothic, I would agree with a lot of that. I think one of the tools that we found very, very helpful is a CNC router, or we use the Xcurve Pro, but just any CNC router. And it's been really helpful. I know one of the things that we did last year was we did two sort of side panels with different bearing locations. So you could put in different ones with different spacings. And so that's that sort of rig idea. And also similar to the different like rods you were talking about. And so yeah, that has been very helpful.
Yeah, I know we're fortunate enough at our school that there are laser cutters. So while you probably won't laser cut a final robot part that'll be on the robot with one of those, that 1/8 inch or up to 1/4 inch sometimes, fiberboard or plywood, you can really faster than the CNC, go make that prototype and come back and test it out within a few minutes. And that's really handy if you have access to one of those.
That laser cutter is also really good for slicing stuff. If you get like before 3D printing something or before properly manufacturing something, if you want to see how something fits, highly recommend laser cutting out a little circle first in cardboard.
And I also want to just bring up a sort of another sort of idea with prototyping that I haven't really heard anyone mention yet. And that is we tried it last year and we had sort of mixed success, but I want to bring it up here because I think it's interesting. And so the idea was, because we do kick off in 2 parts, a Saturday part and a Sunday part. And at the end of the Sunday part, what we sort of said is that afternoon, we gave each person, or each we split the sort of like people who stayed into a few small groups. And then each group would have like 15 minutes to make a quick prototype. And that would be like how to pick up a game piece. And then we would test them out. And it really got us into the idea of like, how do we pick up a game piece and what ideas just flat out don't work. And so it really allowed us to narrow down into like a few certain ideas. It was helpful in that way, but it is definitely a very, very first step in prototyping.
So how Nightcrawler does like rigs is that we build it within the season. So we get the game, we figure out a design we want to do, and then to prototype it, and then we make the rig in the season, right? But we recently realized that a lot of these mechanisms are shared throughout throughout games. Like an intake usually stays the same. You have 2 bars, and then you vary the distance between those bars and vary the wheels. And then for for like a shooter, it's basically the same thing. So I was curious to see if you guys have like preset rigs that you guys use throughout the year.
At Talent, we do the same thing. We don't have any existing rigs. We just have common components. We have some things just to test how much you pull. Usually we just assemble it with like 80/20 and stuff. We don't really have like plan out our rigs ahead of time.
And then I know somebody mentioned that they have like parts specifically for like bearings to put on like 1x1 box. I was curious to see like how many other teams do that. We as Nightcrawler have been looking into like the spectrum blocks that let you basically do the same thing of like putting bearings and motors onto one by one box without having to like use a gusset or like drill any holes.
Yeah, no. On a Mythic, we just use gussets.
The Rev extrusion that they came out with last year that has the pre-cut bearing holes in it, the max tube. We used that a lot last year because you just have to pop the bearing out, you move it 2 inches over, and you can kind of play on different heights for mechanisms, different spacing for arms and chain and belts or whatever you want to do. It's all preset for the 25 chain that a lot of teams use. It makes things. I mean, you just pop a bearing out, you move it, or you slide a shaft up a hole or down a hole or whatever, and it makes it really easy to and quickly prototype without having to re-drill holes or move unbolt stuff. And it worked really slick for us last year. We build a lot of fast, dirty prototypes out of just whatever plywood scraps are laying around, just to test how a mechanism will work or how an intake will function. Just kind of whatever's laying around, and we'll just do a quick and dirty prototype with that. And if it works, then we'll move it on to a different stage. But that doesn't mean that's where we're going to go. We're constantly prototyping different mechanisms, different ways of doing things. And some of them are pretty crude looking in their initial iterations, but we refine them as we go along.
Is it all right if
Kevin,
I just? Oh, never mind. You can go.
Thanks. Kevin, if I could ask, I may not have been listening fast enough. Can you clarify your term rig, what you intend by that?
So it's basically like a prototype that lets you test like multiple different variables at once. So you could make a rig of a shooter where you have 2 plates, and then you could vary the speed of the motor, and then the types of wheels you use, and then the compression within those wheels, if that makes sense. I could pull up an image of one of our rigs here and post it in the chat if that helps.
Yeah, based on that description, 3926 definitely has one we've used in 2020 and 2022 for our shooting prototypes. Basically, it's a wood panel with slots cut out at like different compression amounts, and then we can slide in polycarb, which will just slip around that. And then there's 2 holes cut out for hex bearings. Then we put in hex shaft wheels and motors. And based on that, we're able to test different levels of compression, different wheels, and different speeds to figure out what types work the best for us. Only downside that is it doesn't really allow us to test while also having a back roller. So if there's another shooting game this year, we'll probably redesign it to work with having a belted up top roller, just because, at least from our experience in 2022, missing out on top rollers seemed to be a pretty big deal for us that hurt us a bit. But otherwise, I think we still have it laying around in the shop somewhere.
So if I can follow up on my question, I just want to make sure. So you're saying basically an adjustable proof of concept system that you use for your prototyping or first article, correct?
Yep.
I was just does anyone else have any more questions or want to continue on the current thread? Because For on Talon, it's been kind of a problem for us lately that the way we do prototyping is we give ourselves usually about 1 to 2 weeks. And in order to make prototyping go faster, we usually break out into separate groups, and each group will work on their own specific prototype. But then when we come to try to bring it all back together in a large group, not all of the prototypes seem to mesh together perfectly. Do you guys have a different way of doing it? Do you prototype in large group, or do you have ways of interconnecting prototypes better?
Wait, could you clarify what you mean by like mesh together? Like, are you taking, let's say, like an intake into an indexer? Like, are you using those prototypes together, or do you mean something else by that?
Yeah, about that. Like last year, to give an example, we had just an intake that also worked as like an outtake, but then there are other ideas of using intake to bring it into the robot, and based on that, there were different arms. And so if you went with one intake, you would have to choose a different arm than the other one, because we had like 2 degree of freedom arm and an elevator, and the elevator could only work with bringing the element inside.
Gotcha. Yeah, that's cool. And it's really cool to hear that because normally like, we don't really do that. I don't think. We mostly just do separate prototypes, but I'd definitely be interested to look into that because that sounds really cool.
Have you guys run into any challenges with having separate like prototypes?
I guess not particularly. I think the biggest thing we've run into is just people sort of being attached to their design or the design they worked on. But I think apart from that, it's mostly worked okay. Because then we sort of go in once we have a system decided on, then we sort of go in more and do more in-depth prototypes. And then that's where we would get into integration.
From that, how does your team decide which prototype to choose?
Oh boy, that's a great question. This last year, we had a fun time with it. So yeah, I guess I'll briefly talk about what we did last year and then what we're doing this year. Or Lexi, do you want to go first? Or okay, yeah, because last year we prototyped for way too long, but we just couldn't decide, and so we eventually had to set a specific group in place and say, if we don't decide tonight, we're gonna have this group decide, and that's just like a small group of like 4 or 5 people. And so this year we're instituting a small group which we call MERT, which Liam, can you remind me what that stands for?
That stands for Mythical Emergency Repair Task Force. Or sorry, Mythical Emergency Response Task Force.
Yeah, that's it. Okay, thank you, Liam. Yeah, and so that group is going to be the group that sort of takes control or takes over a decision if the whole group can't make it. So the idea is, I think our schedule's looking at like right now, we have our first week of prototyping, and then after that, we sit down with whoever wants to be in that discussion, and we say, all right, we're deciding on a design now. And then if hopefully in an ideal world, the group comes to a consensus, comes to an idea that like fits the requirements set by the team. But if that doesn't happen, then our MERT group will sort of sit down, which is just, I think, 5 or 6 people. And that group will just come together and just say, all right, we're deciding on this design. So yeah.
Yeah. What I have ironically really connects with what you were saying, Resness, because on Nightcrawler we have the design team. And so kind of what you were saying, Paul, right, where you have these problems where your groups haven't really communicated and their designs don't end up coming together. I think a lot of that for us, because we do generally have different groups prototyping different versions of mechanisms, is that at the end of the day, you know, at least a representative from every group comes together at the design team, and we have, you know, whether it's a scrum or it's just like a check-in on what potential like pros, cons, challenges of the designs are. At the end of the day, we're like coming together as a smaller group and saying, okay, here is where our designs are at. And so I think even if it's not necessarily like you have a design team, but just making sure that your groups are talking to each other, that could help with that.
Definitely. Do you guys have like stationary time or like allotted time to allow your groups to connect?
Yeah. So outside of just normal like Scrum within your sub teams, after our regular meeting wraps up, design team will come together and have, I don't know how long they usually are. I would probably say about a half hour. Just like come together, discuss, set a plan moving forward. And if we're doing that for sure once a week, probably multiple times a week, then make sure that everybody kind of stays on track, hopefully, for where they need to be.
All right, thank you.
And then for like integration between mechanisms, that's where CAD really plays in for us. We don't we CAD like our shooters and our intakes, but most of the CAD is really based off of, okay, how long does the elevator need to be, what angle does it need to be, and like how is the forward bar going to play out. So that's how we ensure that all of our mechanisms kind of mesh. And then if there's a problem, CAD usually steps up and it says, okay, how this isn't gonna work with what we already have. And then of course design team also helps with what mechanisms we want to actually put on the robot too.
Yeah, that's very similar to what Pneumatic does there with sort of geometry sketches. Is that right? Geometry sketches and stuff. Yeah. Okay. Awesome. Yeah, and I'm also now remembering because the past 2 years we've built very sort of separate subsystems, and so in 2022, for example, we only scored in the logo, and we just had one mechanism that did that. But now I'm remembering back to 2021 because that was the Rapid React at home. And with that, because we did an indexer and a shooter. And so how we made that is because this was during COVID times, we split into 2 cohorts is what we called them. But we had one group working on the indexer and one group working on the shooter. And then once those teams had a design, then we sort of sat down and we said, all right, we need to connect these. And so then we went into the geometry sketches and sort of worked around and decided where we would need wheels, where we need all that stuff. But we initially designed the subsystems completely separate.
Do your prototypes like, I guess, for what the final version is gonna look like? Because what we did last year was that our prototypes just focused on the variables that we needed to test to prove that it actually works and does what we want to do. So basically, everything about what it looks like, it was done through CAD. So that also eliminated like how we're gonna mesh these 2 things together, if that makes sense.
Yeah, prototyping really is essentially going through and finding answers to the questions that you have in regards to a game or design. Like, what is the compression that's required? Different things like that, and that help you drive to finalize your design. So you can put those, oh yeah, we need compression of this way in the intake, or maybe then, in our indexing, we need to do this. And then you can use those things that you find out in doing your prototyping to better come up with your design. Make sure, have carpeting down if you're doing an intake when you're testing an intake. Also, a first crack at something, yeah, the drills with the 1/2 inch, driver on there work great on your hex shaft, but you really want to hopefully move towards it being, motorized. And maybe we try to sometimes put it on a dolly or a rolling like chassis or something and move that intake with that whole contraption running on the robot to see how it interacts on the carpeting. Recommend we have pneumatics test board and electronics test board for motors. Electronics has a couple speed controllers on it and a battery, and so it's all mounted down on one little board, so you can carry it over and test it. And you have a variable little potentiometer thing you can get on Amazon for like $15 that creates that PWM signal, so you can control forward and back of the motors. Also, the pneumatics, having that we have solenoids that have levers on them. We purchased. They're not FRC legal, but they work great for instead of getting a little screwdriver in there to poke at the little pilots. And then also, be just as well being safe, we have a relay that's wired so that we actually do have a pressure sensor switch, so that you just leave it plugged in and it charges the tank up to a set pressure, and you can keep using the board and it keeps charging and stopping at the correct pressure without having to unplug it too.
Yeah, and another thing that like helps us have a smooth prototyping phase is that we create a list of those variables. So if you're doing like an intake, we need something that tests our compression, how fast the wheels go, if the wheels need to go at different speeds, what type of wheels we need to use, and like all those variables are made in a list. And then every time we make a prototyping rig, we ensure that that rig accomplishes at least one of those goals. So that eliminates a lot of like overlapping information, if that makes sense.
So how do you guys decide what values you want to test? Is that just kind of like a kickoff thing?
Usually it's like a design team question. So after that initial meeting, we have a design team meeting. Is basically what designs do we think would be viable for this game, and what needs to be done to ensure that those designs work. So just like thinking like, okay, for an intake, what do we need to know for intake to work? Okay, we need to know what type of wheels we need to use. If we were going over the bumpers, if we need a cutout or not. Just like going through those questions of what do I need to get from point A, which is this idea, to point B, which is the finalized version. I don't know if that helps, but
It did help. Thank you.
Also, before you can, shoot or score that game piece, you have to acquire it. So a lot of times, I think we start off with just focusing on how do we acquire game pieces, and also based upon strategy, of that game. Typically there's a human loading aspect, and we have to weigh out if human loading only is practical or not, versus having to come up with other means of acquiring the game piece. But we usually kind of start with that before we even worry about how to score it. We have to see how that game piece interacts. I mean, that will maybe help carry over with how it's scored as well, but just think about how to acquire that game piece.
Yeah, and I think to add on to that, something that was very helpful for Nemythic last year was that we had an old drivetrain in the shop that we could use. So we hooked that up with some programming and then just slapped some intake prototypes on there and just sort of saw, like, when driving around, how can we interact with game pieces, which was very helpful.
Exactly. And just having old robots where you can, depending upon the game, vary the bumper height. If the bumper zone changes from one year to another based upon usually a game piece size, worrying about, are we going to get stuck on this? Is that game piece actually going to be able to get under our robot or not? And how much of a concern is that if it does or doesn't, so, having an old robot, and even if you have, you can maybe hopefully adjust the bumpers pretty easily on it and drive at speed at different game pieces and see, do we just deflect them away or do they get stuck? Because, it's going to happen. You're going to get on a game piece and it's going to ruin a match. So trying to ensure that it's not going to happen.
Yeah, and I think especially with the rise of Swerve, this is maybe going to be easier in future years, because I know for 3926, our plan is to have our drive base done within the first week of the build season. and it's going to be done by our electrical sub team, which is a little confusing and weird why our electrical sub team has built our swerve base all 3 times we've built it so far. But it kind of has happened, and so we plan on continuing it that way because our electrical sub team generally doesn't have too much to do during that first week anyways. And so being able to, decide on a frame size, then cut out those pieces of 2x1 and just, bolt together the modules and then wire them up, which is really the hardest part of it. That's going to be hopefully helpful because then once the prototypes are done by the end of that first week, we'll be able to potentially test them on the robot.
Yeah, the making the frame thing in like the first 2 weeks is super important. Because it also just allows your programmers to start testing autos and auto pathing. And then that goes back to balancing your mechanism with how mechanically complex it is, and then like how easy it is to program. But that I think that also plays into like optimizing your use of CAD. Basically, like, does this really need to be CADed right now? And what can be done in CAD that doesn't need to be physically prototyped? What needs to be physically prototyped? And just like figuring out that list of to-do items is really important. And then that also plays into basically like reducing the amount of trials within prototyping, because prototyping is a lot of trial and error, and I feel like the way to make it go faster or to smoothen out the process is to by removing the amount of trials you have to do. And then I feel like how that's done, or mostly, is what you do before you actually start prototyping.
So let's get that from
We can't hear you that well.
yeah, you can. I wanna better words, maybe? Okay. My question is how long do you prototype for, and when and how? Well, I guess we're from now. When do you decide to be done with prototyping?
On Talon, we kind of have more of an ongoing prototyping. We create like a schedule with several points that we need to hit. We want to pretty much get a really solid view of what we want to prototype or like finish different models of prototyping. And then we present those models to the team and do a like pros and cons session, and we decide which ones we want to pursue. And that is, we call that our team design review. And then we have like 3 or 4 days to then try to attempt to integrate everything together. And then we have a design review committee in which we request mentors from like all across our team. We have company sponsors that come in, and we get a lot of experienced people in one room and just tell us all the ways that we're wrong and ways to improve them pretty much. And usually after that, we give ourselves another like 3 or 4 days to pretty much improve as best we can. And then by that point, we have to start worrying about manufacturing our drivetrain and really starting production on the robot. So we have to send off drawings to company sponsors to help us like weld together a drivetrain and things of that nature. So that's usually when our prototyping kind of ends. But we can make little adjustments to our subsystems on there as well.
As part of our push to make our prototyping faster, we first kind of decided going into the game, if it's gonna be like a pick and place game, we're gonna go with an elevator, and if it's gonna be a shooter game, we're gonna go with a non-turreted like hooded shooter. So that way, right after kickoff, we are planning on getting a rough kind of master sketch in CAD done. That's parametric. So then, like what people from Nightcrawler was saying before, we can find the variables that we need and just quickly change that. And I think we're trying to have like a prototyping cutoff so that we can build kind of a first version of the robot and just get that off to code team. And then all the design people from there are going to be able to think about, hey, how can we improve this? And then make almost like add-ons to put on the version 1 of the robot.
For Nightcrawler, our season is kind of split into we spend the first kind of week researching different ways to complete the game. Then we usually spend around 2 to 3 weeks prototyping. And then the rest of the time is just fabrication, handing it off to controls. We usually try to give controls around 2 weeks to program the robot.
And then do you guys participate in week zeros at all in order to get driver's practice? I believe you guys run one, now that I'm saying it.
Yeah, we host a week 0. And as part of that, we have a parent crew that builds all those game elements. I know most teams try to build the important or the team aspect of those. It's really important to do that. Some are really simple, some are not so much, or how well they approximate the real field. You know, you kind of have to look at the real drawings really closely to make sure that those critical details that make them a difference are in that team version that you build. But we will usually go back and tell those parents that are working on building what are the most important things we need. So like last year we said we need at least, 1/2 of one of those charging stations right away, so we can work on, how easy or hard it is to balance. And I think we found that the wood one we had was almost harder, I think, so than the actual one, because it was also a half and not a full width, which we had more mass with that. So yeah, it definitely helps, but I don't know. We don't usually get it to all set up onto a whole field until the night before, and we get on there at the same time usually as everyone else at week 0.
Yeah, and I guess the question with that is like, to what degree do teams build field elements? Because I know last year the charge station sort of had 2 versions. I think it had the one with like just the like pipe or something, and then the one with the hinges. Because for No Mythic, we went for the one with the hinges, and that probably took us a week or 2 of milling, where we just couldn't use the mill because we were just making those steel hinges, which took a long time.
Has any of the teams looked into, I know this is a different topic, April tag for next season and how one is going to use it? I'm not sure it was extremely useful in the last year, but what are other people's opinions and how are people approaching that?
Our programming captain for the past few months have just been by himself working on April tags, trying to figure out how it works and whatnot. So we're putting a lot more emphasis on trying to use April tags because of how it tells you exactly where you are in the field. So it makes autos, or it should make autos a little bit easier.
I can expand on that a little bit. Hello, everyone. Sorry, I'm an hour late. I was out of town and just got back. So our goal with April tags is to be able to reset odometry during during auto. So last year, if you tried to do a 3-game element auto, you'd leave the grid, pick something up, come back to the grid, leave the grid, come back to the grid. And every time you approach the grid, you would have had the opportunity to reset your odometry so that any slippage you had in your swerve modules or tank drive, if you do tank drive. But when you turn really fast or you accelerate really fast, you get slip. And so over time, you sort of drift off of where the robot thinks it is compared to where it actually is. And so in your auto routine, you could have a command that would read the April tag, get the position of where you are in the field that the April tag tells you are, and then reset your odometry to match so that your next step of scoring or lining up or wherever it might be will, in theory, be more accurate. And if you had some type of an autonomous assisted scoring element for next year during teleop, so you got close and you hit a button, and then from that point, a command would take over and drive you up and score or whatever the game is, you would do the similar thing where you'd reset your odometry, and then you would run a command that would drive you to a different position and then shoot or place or whatever your robot does. So that's our approach for April tags. If we're doing shooting, then it'll be very similar to how we used to do things with reflective tape, where we'd identify where's our target, how far away is it, and then we would, ramp up our shooter to whatever speed we needed to be an aim.
On that note, you can also buy a Google Coral now, which you can plug directly into a Limelight. Ian has also attested to how useful these things are. Pretty much, the Limelight gives you a tracking thing where you can automatically track game pieces in relation to where they are in your robot. So you're pretty much 100% accurate in picking them up. It's kind of cool, not super necessary, but it's a nice to have.
Liam, did you buy one of those recently? The last time I heard about Google Coral, there was like an 18-month waiting list.
Yeah, they're actually pretty open and pretty cheap now on Amazon.
I know I bought it right at the I bought the one for our team during the shortage. I got a notification from one of the trackers that I was using that it was on sale, and then I impulse bought it, and so it's actually mine and not the team's. So hopefully it doesn't break on the robot or anything, or maybe I'll get paid back for it at some point. But we were able to use it to track game pieces and auto align to it, which was super useful. Especially this year with the relatively smaller game pieces, the precision it took to align to them when intaking could be tricky sometimes for drivers. So I think that for the teams that use Google Corals, it's going to be a game changer. Although I've not checked the stock of them recently. So assuming that they're still in stock, I think the hardest part of the process was obtaining one. And then after that, it was just like the rest of Limelight coding, where it's like you plug it in, and then we were tracking game pieces within like 15 minutes.
How many I guess designs do you guys start with, or have to prototype within the season? At Nightcrawler, we try to narrow down the amount of designs we actually prototype as much as possible, and then that's a part of our kind of reducing the amount of trials it takes to get something working.
I guess for Nomythic it varies a lot depending on the year. There are years where we just prototype one design per system, and there are years where we prototype 3 or 4. Because I guess how we do it is we sort of sit down at the start and say what are ideas that we could use for this, and then it's just depending on what the team wants to prototype.
For Talon in the past, what we would do is we would pretty much put for all of our acceptable prototypes or things that we think would work, and we would narrow it down until we couldn't eliminate a prototype. You can usually consolidate prototypes together or rule one prototype out as either inefficient or having like a glaring weakness. And we just narrow that down until we have prototypes that would definitely work, or we could see them working, which is usually about 2 or 3. Sometimes if we're lucky, we'll get it down to 1 and we'll just get a consensus. But usually 2 prototypes per subsystem.
And then I guess that brings or like that goes to the next question of what's the process of actually like narrowing down designs? What do you what's your criteria? Because for Nightcrawler we have our design tenants, which eliminates most of them, and then we also have the design team, which helps us focus on okay, uh this is probably what we're gonna see. Um and then that usually leads us to 1 or 2 designs.
So we try to create a strategy analysis of how to gain points and different like drawbacks of choosing different methods of playstyle in the season. We use that as well as just massive pros and cons lists, as well as a lot of informal design like principles that we have among our team. And usually we can all pile that together to kind of create a consensus of what type of robot we want to make. We also do goal setting about what placement we want to be, whether we want to be first pick or a team captain, or if we want to end up being like an Einstein compender, or just to do well at potentially getting to state. So that also influences our decision quite a bit.
Yeah, and I guess for Nomothic, because yeah, we do something kind of similar with the sort of kickoff sort of strategy, and using that. But a tool that we sort of used in the past is a design matrix, and that's just to remove some designs. That is, we've just used like a Google sheet to sort of put some different, I guess, things that we want, like simplicity, speed, and like some different, I guess, ideas that we want the systems to have, and then we rank them out of 5. And that it can help remove a few of like many designs, but it's not great to choose a design. I also want to bring up, because I don't know if any of y'all saw Jack and the Bot's presentation like a month or 2 ago, but they brought up a really interesting idea, which I kind of liked. And that was the definition of consensus, because they said that consensus doesn't mean everyone agrees that it's the best idea, but everyone agrees that it meets the requirements and principles that the team set, which I think is a really cool way to look at it.
Was the presentation like slides, or was it like Zoom type of?
It was streamed on YouTube. I can try to find the link and put it in chat.
Yeah, I mean, strategy basically guides our robot design for Nightcrawler. Just making sure that well, we pick our strategy through the human robots and whatnot, but then we really try to focus on if our mechanisms meet that criteria of okay, we want to be able to score on the high note, and then really focus on audio and whatnot.
Do you guys have more separation between what you want to design for like design around like how you want to play the game, and then the mechanisms that you use for that? Do you guys like keep those like talks kind of separate?
Initially, we try to keep it as general as possible. So for the human robot archetypes, we try to say, okay, instead of focusing on mechanisms, we just say this robot scores on a high note, and then balances on the chart station, and then that's it. And then after that is where we get more into the mechanisms of, okay, how do we um, most effectively like score on the high node while completing these other objectives. So we try to keep it as separate as possible at the start of the season, and then as we get more into our design process, that's where we start incorporating mechanisms.
Yeah, I think to your point, Paul, um, the overall archetypes that we end up choosing are informed by the strategy that we think is going to earn the most points, right? Whether, for us that might look like, okay, the strategy that involves prioritizing auto and prioritizing a certain level of scoring or a certain behavior during endgame. But then, but in terms of, like Kevin was saying, we keep that pretty general until we get very specific in prototyping.
We're trying to focus in more on splitting those two talks, because last year we decided that we minimal cycle times was the best way to get points in last year's game, and so we were thinking that floor pickup was going to allow us to cycle quickly, and then we got more involved with the floor picking up method than realizing whether floor pickup was a good idea, because there was only a limited amount of floor items. So we got caught up in that and didn't place too well at our first tournament because of that, design oversight.
Yeah, it's definitely a struggle to keep those two things separate. We to try to help mitigate that, we do mini trials introduces the idea of trying to keep those two separate, but also creating I guess goals of or for our archetypes to choose out of. So instead of getting into that rabbit hole, we preset okay, this is what our archetypes can do, and then we base off our archetypes off of that list. But yeah, it's a struggle, and there are times where we go through that rabbit hole. So
A question I have for people is, how do you tell someone that their design is probably not the best way to go forward? Because we want to encourage people to make their own things and stuff, but then we also don't want to waste time, especially with a smaller team. We don't have that much resources to go into things that probably won't end up working.
That's a really good question, because especially in a space like FRC, right, we want to encourage and lift everyone up. And so what we try to talk about on our team is this concept that, right, it's when we're talking about designs, it's a safe space, right, where once this idea gets put out there, it's no longer the person's idea. It's more of it's an idea that the team can go down the path of, right? And so that means whether good or bad, right, it's not just necessarily any one person's idea. And so our goal is to respect every idea, so we don't want to laugh at an idea and be like, haha, that's stupid, right? But at the same time, right, we can talk about how it's a safe place to share your ideas, and everyone's ideas are valued, and we want as many ideas as possible to be shared. But then we kind of take a look at them realistically as a full team. We do basically what's a design review, where we ask a set of questions about them, and it either sometimes shows if it's been really well thought out, or 90% of the time there's, the first ideas, there's always something that we need to change or look at really closely. And so by asking those questions, we kind of figure out what still needs to be looked at in ideas. But generally we try to teach those strong principles at the start. And the other area that divorcing the creator of an idea from the idea is that a lot of times people, I'm also guilty of this, can get really emotionally attached to what they come up with, where it's like, I came up with this, specific type of shooter, right, that I really want to do. And that emotional attachment a lot of times can cloud better judgment of what's going to be the most successful for a given team. So that's also something to always be looking out at.
I would also say just making sure that the design tenets that we're going to use kind of like as a rubric are well known, and structuring that discussion around like, this is just an objective way that we're judging all of the designs, right? Every design is subject to, does it fulfill touch and own it, right? Does it fulfill these other design tenets? And kind of making sure that we're treating all of our designs that come up equally, but still holding them to an objective standard. And I think there's a way to have that conversation where we're not judging anybody's ideas, but we are holding them to a certain standard, and that's the team standard. And kind of like removing it from judgment and putting it more on just like, where does this rank on the rubric of things that we want our design to be?
For us, we use a lot of pros and cons lists, which they have a lot more power than you probably give them credit, by just putting out all the potential problems you have in front of you and just seeing two ideas compared. It kind of takes some of the emotion away from it just by just seeing problems on a board, but also it like the different like severity of the problems and how much there is really helps compare the ideas, and it takes it more into like an information like factual zone about like what is possible with your team. And so we use a lot of that, and it usually gives a pretty fair idea to all prototypes, because most of the team has a say in the pros and cons list, and so we usually get a broad perspective.
One of the things that is hard in FRC, but is so important, is to assume that your high schoolers have. I'm a student. I shouldn't say you are. Assume that high schoolers have emotional maturity even when they don't. And so I always ask my team to consider people from the other perspective, to put yourselves in their shoes, and most importantly, to always remember that we have the same goal, and our goal is to get the best robot on the field possible. And so if your design isn't the best, then great. Your goal is to get the best robot, not to have your design on the robot. And it's a hard ask, but to ask it is to put trust in your team and to ask them to grow. That's just me.
Yeah, and also going along with that, something we try to emphasize is that even if an idea isn't selected, right, it's still contributing to the team in other ways, because a lot of times ideas can kind of like get merged, or later on, it can be thought of like, oh, we can add this from one design. And even if it just gets us a better understanding of how the game is played, almost every time an idea is shared, whether or not, it's a usable idea or not, it still, helps get an understanding of how the game is played.
No one's commenting, so Kevin, if I could jump in, I don't know if this is a good question to ask at this point, but do you ever, is it fair to discuss the distinction between R&D and prototyping or first article? Do you have any, is it worth talking about preseason or postseason, non-build season prototyping and whether teams do much in that capacity?
Yeah, I mean, I think that's a great question of like if teams do any prototyping in and out of the season. We for Nightcrawler have a bunch of different projects that we have running throughout the season. So either that's the Rummies, that's the T-shirt cannon. We're already always trying to like be having or like working on those prototyping skills. And just like staying in that mindset of what is the best way to accomplish this and how do you get there? I don't know if that answers that question.
I would also say, if we think about historically, at least when I've been on the team, we've always been we have a Duluth, like week 1 regional, and then later we'd have like a North Star 10K, that's week 5. And within that 4 weeks after Duluth, we've learned a lot about the robot. We've learned that we need to make certain parts more robust, or we need to tune our autos a certain way. And so I think encouraging students to like, yes, build season, the intense part might be closer to over, but there's always things that we can do to keep improving on that design and getting it where we want it to be for state, or for champs if we qualify, things like that.
Kind of adding on to that, I am curious to see how much you all iterate like during the competition season, because Nightcrawler historically keeps it more towards improving the autos rather than trying to improve the mechanisms, because we usually don't want to change something, have it break, and not be able to fix it before the next competition. So I want to see what your all's philosophy with that is.
Yeah. So last year, Nomothic sort of went down the path of having a different robot for Duluth and Minneapolis because we went to those 2 regionals. And I think we can safely say that we did not like that strategy. Because we had a floor robot for Duluth because we didn't have our sort of arm or our tire square mechanism done. And that first if you're going to do regionals, it's very helpful to just stick with the same one because you're able to sort of iron out the kinks in that first regional. And so, for example, going into our second regional with a new mechanism, we didn't really know any of the issues that we would face with that. So we got there and then a bunch of stuff was breaking, but it was a lot of fun and we did all right with it. So it was a lot of fun though. But
we kind of have a differing philosophy. We try to prepare as much as we can for our first tournament, but we usually have a second tournament. So we try to also learn as much as we can at our first tournament. And so usually between our first and second, we go through a major design change. Last year, we went from a floor pickup bot that would have like 3 different handoffs to having active intake on the front that is its intake and outtake. And we completely like changed up our like arm and lifting mechanism for it. But we find that making those design changes and realizing the problems with your robot allows you to be a better robot later in the season and continually getting better and better, so that by the end of the season, you can compete very highly and very competitively with other teams.
Did we also modify our elevator or our climber last year?
Are you talking Rapid React?
Yeah.
Yeah, we did.
Totally redesigned that as well. So.
Yeah. So for context for everyone else, in our first tournament, we realized that we weren't going to be able to make traversal. So we went with just a simple up and down climber in a box with hooks on it. And then in between our first and second tournament, we added in some swinging arms to that allowed us to go from mid to high to traversal. And so we were able to use that extra time to really finish what we wanted to do originally with our robot.
Right. Are there any more like questions or comments? All right. It is 8:32, so I think this has been a great meeting. Thank you all for participating and commenting. So yeah.
I will drop the link to the meeting notes and also the link to sign up for a topic. Anybody sign up if you got a Jumpstart presentation. If you have a question that you want other teams to answer, I'll drop those links. Feel free. Anyone and everyone, welcome to lead a topic.
Thank you all for your input, by the way. This was a very helpful meeting for me.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.